Welcome back, viewers. So, we were understanding the importance of explainable AI in understanding how the machine learning, or you can say the machine model, are behaving in a certain way. So, it tells us how important a particular set of features are and what is their contribution for a particular model outcome. Now, let's understand why there is a need for XAI. We are all satisfied with the AI performance, but as the application becomes critical, application gets more amount of data, this need for XAI arises. So, as of now, if we are not performing any kind of explainable AI, then we will not be able to understand why a particular set of prediction came. Why you can say there is decision making towards some specific output. So, there has to be some explanation for this. Let's take one example here. So, as of now, if we are not using XAI and we just want to develop a model that gets trained with a set of images of, say, pets, it could be cats, dogs, and all, and then we are training the model, and then once the model is learned, is trained, we want to test by giving a you can say a picture of an animal, of a pet, and try to make the model predict whether it is a cat or a dog. So, if the model is correctly predicting, say for example that the model has got properly trained and it is predicting the testing image, the cat, as a cat, but still the user with the output will not get to know why the model has identified a particular picture of an animal as a cat. Now, here the XAI becomes very useful, where it says that why it is a cat, because it has certain features, okay, because it has claws and whiskers, therefore it is a cat. So, this is a very simple example. So, in this case you can see only two features, the whiskers and the claws. Try to imagine when there are hundreds and thousands of features and one wants to know for what reasons, for which particular set of features the machine identified image as a kind of an object, why the classification is done, why there is a some trend, a particular trend is predicted. So, the question to these kind of whys is given by XAI, and hence the need of XAI is justified. If we take one more example, say from the healthcare sector, say we have a model that detects whether the disease is a flu or a fever or something else. So, for example, say the model is properly built and trained, and now it is tested for a patient who has certain symptoms, and the model is saying that it is a flu. So, if we are applying an XAI, we will get to know why this model is giving the output as flu. Maybe because the person is having a headache, or some kind of sneezing behavior is there, but no fatigue. So, there are some yes and no checks whether this is happening, yes or no, whether the patient or the person is feeling some kind of weakness, yes or no. So, when we take up all the the behavior of a patient, all based on all these features, then we can understand through the lens of XAI that yes, because of these particular set of symptoms, the model has predicted flu for the patient. So, why the model is behaving in a certain way for a locality of a data point X is answered by XAI. So, locality of a data point X means we are referring to the sample, in this case one patient. So, similarly, there could be different types of queries to understand AI. So, it depends what kind of questions we want to ask to understand the AI functioning. For example, is the AI's performance good enough? Good enough is a very abstract term. It means that whether the accuracy is up to the mark or not, whether the risk and limitations are, whether the risks are more or it's compromisable, or maybe we want to know that has the AI model made some mistake? So, is it reliable also? Again, there could be instance based prediction. So, all these were kind of general model behaviors. So, whether the model is good enough, is it having risk, is it reliable? So, this kind of questions are there. But there could be some questions that are based on a particular instance. So, like why is the instance has been predicted as X, why not as Y? And what kind of changes I have to make or I can make to make the prediction not as X but as Y. So, these kind of regulations, like if we want to tune the parameters, which parameter exactly we should focus on, these are making very much clear by the XAI. Now, when we have the questions with XAI, then there has to be answering with XAI. Now, XAI has different types of models like SHAP, LIME, many other models, ELI5 and several other models are there, which helps to understand why the model is behaving in a particular way, how we can change the prediction from X to Y, or is there a need altogether to do the changes, or if we are doing the changes, then will there be some repercussions on the model performance or not. Now, we have understood what is AI, what is XAI, what is the need, along with some examples. Now, let's understand from where the data could be coming. What kind of data we are looking at for the XAI to perform. For simple data, obviously, we can have the simple statistics and mathematics at hand that we can do. At most, we can build up an algorithm and make it, operate. But when the data is coming from the real worlds, like the power grids data, which is huge, because there are transformers everywhere, the distribution of the power, the carriage of power. So all these are generating huge amount of data that has to be taken care of. Then it could be the social media data. So from each post, huge amount of data is generated, and such posts are being being posted on the social media all the time. From there is no stoppage to that, and there is not one one social media. There are numerous social media available. So you can now imagine the colossal amount of data that we are talking about. It could be our mobile phones, it could be the surveillance data, even it could be the field sensors that could be deployed, for example, in the industrial sectors to capture the continuous monitoring of the blast furnace and all, or the temperature that AC is being operating at, should it be smartly be raised on or lowered down, those kind of things, those kind of decision making, or the sensors that are in the agricultural field to find the right set of moisture and temperature, etc. in the soil, in the environment, that can be helpful for production of a specific type of crop. It could be in the medical field, in the space explorations, banking transactions. So all these sectors, they are generating enormous amount of data. So these are the fields from where the data is coming, and we are very much concerned about how these data sources, this vast amount of large scale data can be used by the AI systems. And even if the AI systems are able to capture the trend in the data, how we are going to understand that what kind of data, or you can say what kind of behavior the machine has understood. Maybe there could be some kind of some incorrect behavior capture, so that all those things gets transparent when we are using or applying explainable AI. So this is a kind of framework that you can see it on the screen. So there are different ways that we are getting the data. There are data pools, data lakes, from the apps, from the files, from the cloud, and so many places from where the data is coming. And then we are capturing the data and storing it, and on those data, when the models are built, we can apply the XAI model. Now when we are doing XAI, we are doing some kind of processing before the data is taken to build the model, and we do some processing or some analysis of results after the model is built. So the different types in which the AI can be observed or employed in a system. So before going to the types of XAI, let's understand some of the features of XAI. What makes XAI so popular? The first is the understanding part. Understanding is linked to the human ability to spot connections. So the first thing XAI does is to identify the connections, why it is happening, what is the mechanics, how the model is going to operate in a particular way, what is the role of each operation for the model to perform. Because when a model is built, there are different set of operations. So maybe some of the operations are inevitable, and some could be like driven by certain kind of set of features. So we have to always understand which features are impacting more or less to the outcome of a AI model. Next is explicability. This refers to the ability to examine the characteristic of the data. So first was to understand, and then was to examine, to probe into the AI system, that why this kind of behavior or why this kind of decision making is happening. Then the very important thing is the explainability. So it goes a little beyond what the explicability is, by making the perspective of the AI system logic, the findings, the judgment. So this makes XAI even more, you can say, easy for the end users to comprehend it. Then the transparency. So transparency is whatever algorithm is built, whatever model is being designed, how the procedures are being, executed. It could be as simple as what kind of branching mechanism is used, or there is some parallel processing, to the complex decision making, like say if there is a drift in the data or drift in the feature, then how the system is going to behave. Now what is this drift? It can be easily understandable, like if we have a set of patients' data, say for example, and we have the symptoms and the treatments going on for the people, the medications that the patient is taking. Now if we have some 100 patients' data, okay, for past maybe few months. Now if for the upcoming month some new disease is coming up, then the patients may be showing a different trend of symptoms to a particular disease. So, when the data gets added on, data means the samples altogether of the patients are getting added up to the system. It's augmenting the data. So that is the data drift. What is the features? When we have like more features, we are adding more features, we are adding more columns to the existing data. It means that we are adding more context, we are adding more features for the model to perform in a better way. So there could be the drifts also, and XAI very much helps to understand this transparency across the data and the content drift. Then the interpretability. This helps that how the AI system judgment can be understood in two ways, globally as well as locally. Globally means that the whole of the model taken together. So for example, if we are talking about the accuracy of the model, how the model is behaving, is it accurate or not? So it's a single score that we get. So the score is generated across, many samples of in the data set. It could be like across 1,000 or maybe lakhs of samples, and the model is giving some accuracy. So it's kind of an you can say average behavior of the model. And again, then there could be this local interpretation. Local interpretation means how a particular sample is behaving, or why a sample or a row is being classified into a certain class. So these things, either we go globally or locally, interpretation of a machine learning system is very much required. So this helps to understand the internal decision making process. Next is correctability. Correctability here denotes the capacity of an AI model to be focused by a human actor to guarantee the right choice. So how much correctness, the degree of correctness, so as to guarantee the right set of choices. Then obviously, when so much flexibility we are getting from XAI, there are two more, that is the interactivity and the comprehensibility. So interactability is you can interact with the system. If you remember, there was a question that what if I want to change the prediction not as X but as Y? So we can make some changes based on whatever interpretations XAI is giving to us. So that imparts interactivity. And there is comprehensibility also. It means that now a person with limited domain specific knowledge also, if he or she views the XAI results, can get a lot of interpretations out of the model performance. So all these features makes XAI very significant to understand the machine intelligence. Now let's understand the XAI taxonomy. So there are 4 ways that we can understand. So let's see how these categorization can be seen in more detail. So let's check the first one, generalization. So XAI categorization based on generalization. So the first one is ante hoc, or you can say the intrinsic. It means that it covers the models which have a interpretable internal structure. The internal structure is not very complex. As you can see in the example, that here it's a tree structure where based on age, the person is being classified in a particular class. So such kind of structure of decision tree, or you can say the internal structure of the shallow structure of a tree, these, when we have these kind of data distributed in this fashion, then the models that are applied are the intrinsic model. And just opposite to this, when we have more complicated tree structures, especially the deep neural networks, therein the post hoc XAI generalization is applied. Next one is the model agnostic. Model agnostic is one of the post hoc type of the generalization in XAI, where you can say that the models that do not have direct access to the internal weights, internal model weights means the internal parameters that we are using. Maybe we are not very much concerned with how the internal model weights or the structural parameters have to be accessed. There is no direct access to it. Then these kind of model agnostic methods are really helpful. They are not limited to a specific type of model architecture. They are very general models that can be applied to any kind of AI algorithms. So, some of the examples are SHAP, LIME, ELI5. So, these are some of the very prevalent XAI post hoc methods, model agnostic post hoc methods that can be applied to any AI, or you can say the machine learning algorithms, and we can see that why a certain type of feature is behaving towards the model outcome. Okay. Next one is model specific. So, again just opposite to the model agnostic is model specific. So, now we are very much specific to a particular model. There is a particular model and we want to have a special type of model specific XAI method. If this is the case, then we go for model specific methods. Like if we want to develop a XAI method for a graph neural network. So, when we are talking about a graph neural network, it means that there has to be a certain kind of topology associated with the graph, and for that only the neural network has been constructed, and whatever XAI method we are going to develop should explain that specific GNN. So, this is where the model specific becomes important. So, like for different types of models, as the if we want to have examine this model accuracy and the model interpretability, a trade-off between the accuracy and interpretability, we will see that there are certain models that are high in accuracy but maybe low in interpretability. So, it depends that what kind of application data you are working on and whether you have the interpretability more important, or you want to focus more on the accuracy. You want to see why the model has made the decision, or you are like satisfied with if the model is giving you good accuracy. So, likewise you can choose any of the model that could cater to your application. Now, next one is XAI categorization based on the scope. So, as just I was talking about, we were discussing about the scope. It could be the global or it could be the local. So, global methods, they concentrate on the intrinsic parts of the model, how it is behaving. By exploiting the knowledge about the model during when it was getting trained, what kind of parameters and hyperparameters were involved. So, all these things all together, they explain a generic behavior of the model. So, there are some models that are global, some of the models are local. So, local models are applicable to a single outcome of the model. So that is sample specific. So it could be like we are interested to know which specific features and characteristics for a given sample, then the prediction analysis is it becomes local to a particular sample. Then there are categorization based on the stage when the XAI is going to be employed. It could be pre-model, or it could be in model, or it could be post-model. So pre-model means that you are doing some kind of exploratory analysis with the data and want to see how the data is distributed. So there are some examples like principal component analysis, T-distributed stochastic neighbor embedding process, in short it is called the TSNE plots. And for in model, it means that the model building is ongoing and we want to see how the model is getting trained epoch by epoch, each of the training phase. Then it is called the in model methods. Similarly, you have post model methods that gives you an idea when the model is completely trained and now it is performing in a certain way. So to understand the model behavior post training way. So these are some of the categories where XAI can be applied. So again, based on the application, based on the scalability of the data, the distribution of the data, the different features associated with the data, one can choose the XAI model, the XAI category, and can make their machine learning models transparent and understandable to the end users. So in this lecture, we wrap up here. For the next lecture, we'll more explore about the XAI challenges and usage. Thank you, users.